Using exists or not exists, we can check in SQL whether the result of a subquery is empty. So whether the subquery has returned any rows. Here we have an example query that returns the students that have not submitted any homework. A few slides back we have seen how this can be solved using not in. Now we are solving it using not exists. And the not exists is true if the result of this subquery is empty. So what does the subquery compute? The subquery selects all the rows of the results table where the category is homework and the student ID of the result is equal to the student ID of the student that you're looking at in the outer query. And this is an important difference to the in and not in queries that we've seen before. This query depends on the outer query. In the inner query, we reference a tuple variable of the outer query. So for different students, we will get different subquery results. We also say that the outer and inner query are correlated, or we say that the inner query is parameterized by the parameter s.sid. For the not exists, the inner query should always be parameterized. If the inner query is independent of the outer query, then no matter what tuples we look at in the outer query, the inner query will always be the same, and the not exists will always be true or false. So then we can simply replace it by true or false. It's just a constant. So for the not exists, the inner query should always be parameterized. And this is a difference with the in and the not in. For in and not in, the inner query can also be parameterized, but it also makes sense to use it without parameters, because we do not simply check whether the table is empty or not, but we check whether a certain value appears in the table or not. So looking up whether a certain value appears in the table, this also makes sense if this table is a constant. Checking whether the table is empty does not make sense if the table is a constant. So very important, you always should use parameterized subqueries for not exists. Let's have a look at this query in a bit more detail. This tuple variable s will loop over the 5 rows in the students table. And conceptually, the subquery here will be evaluated each time. So it will be evaluated 5 times. Of course, the database management system may choose a more efficient evaluation strategy. But the outcome of this strategy should be the same as if the subquery would be evaluated each time. We can imagine the evaluation of this query as follows. S loops over the rows in the students table. So first S will be assigned the first row, George Orwell. George Orwell has a student ID 101, so the subquery will be evaluated for sid, for s.sid being replaced by 101. So we evaluate this subquery, giving us this result. This result is not empty, so they exist result rows. That's why the not exists is false, so George Orwell will not be included in the output of the outer query. We have skipped a few steps. Now finally, S will be assigned the last row in the table, in this case George Washington. George Washington has the sid 105, so we evaluate the subquery for s.sid being replaced by 105. This gives us an empty result. Now the result is empty, so there are no result rows, so the not exists is true. So George Washington will be included in the output of the outer query. So in the subquery, we are allowed to reference tuple variables that are declared in the outer query. However, the converse is illegal. We are not allowed to reference tuple variables in the outer query that are declared only in the inner query. And the reason is, of course, that we have a variable scoping similar to all usual programming languages. The variable R is declared locally in the subquery, so we can use it in the subquery, but we cannot use it in the outer block. So this is very similar to blocks in programming languages Java, C, C#, Python, and so on. I've said it before, but it cannot be stressed enough. If you're using exists or not exists, then the subquery should be correlated with the outer query. If you have a subquery that is not correlated, it's almost always a mistake. The reason is that such a non-correlated subquery evaluates to a constant table, independent of the combination of tuples that we are looking at in the outer query. So the exists or not exists will always evaluate to the same value. And this is different from the use of in or not in. In combination with in or not in, such a non-correlated subquery makes perfect sense, because then we can look up whether a certain attribute value appears in this constant table. But with exists or not exists, we are only checking whether the table is empty or not. This slide shows an example usage of exists without negation. Here we have the exists. This query computes the students that have submitted at least one homework assignment. In the outer query, we are querying data from the students table, and we are outputting their student ID, first name and last name, if the following condition holds, namely if the following subquery is not empty. The subquery looks at the results table. It selects those results that belong to the student that we're looking at in the outer table, and it restricts the homework results. So the subquery will be non-empty if there is a homework result for the student S. So we include the student in output if there's at least one homework result in the results table. Now the question, can we reformulate this query without using exists? So let's give it a try. We want still the student ID, the first name, the last name. We want to still query the students table. And since we do it without exists, we also want to query the results table and join it with the students table. We need a join condition that says that we're only looking at those results that belong to the student that we're looking at. So we should say that s.sit is equal to r.sit. And we only want to look at homework results. So we say that okay. Now that we are querying the students and the results table, the student ID in the select clause sit is ambiguous. So let's try. Indeed, the database management system rejects this query, saying that the sit in the select clause is ambiguous. So we have to disambiguate. They're anyway the same, so we can select either S or R. So now we have a table of all the students that have a matching result, a matching homework result to be precise. But there's still one thing odd, namely several students appear multiple times, like George Orwell appears twice. So are we allowed to simply filter the duplicates by adding distinct? So first of all, we should think, why do we see these duplicates? Is this possibly a mistake in our query? In this case, we see the duplicates. Let's say that we are looking at student George Orwell. Then George Orwell has the student ID 101. If you're looking up in the results table, George Orwell has 2 homework results. So this is exactly the reason why we are seeing George Orwell twice in the output, because there's 2 result rows that fulfill this criterion. So we have 2 combinations with different result rows, so we see the student double in the output. So indeed, we have understood that this is fine, so the duplicates are natural, so let's eliminate them using distinct. Now another question is also, if we eliminate using distinct, may we eliminate duplicates that we still want to see? So if we have two students with the same name, may we accidentally eliminate the second student? This would be the case if we would have only the first or last name. Then we could not simply add a distinct, because then if you have two students with the same name that have submitted a homework assignment, then the second student would be eliminated by this distinct. However, if we also include the student ID, then this cannot happen, because the student ID is unique for every student. So we only eliminate duplicate occurrences of really the same student. If there's two students with the same name, they still have two different student IDs, so they will still be present in the output. So this is just to say that before you're adding a distinct blindly, you should understand why you see the duplicates, and you should also consider, if you are adding the distinct, do you remove things that you actually want to have double in the output? In this query, it's fine to add a distinct.